In this video, I'm going to go over 3 problems for the Unit 7 test to kind of help with the larger concepts, the things that require calculations. So I have on here the z-table. What I noticed with some of the answers is that the values are a little bit off from what's on the z-table. So maybe it's because of rounding and that. So I would just pick the closest value to what you get on the z-table if you come across that problem. And if it was a different number and you can show me your work, I can add some points to your test. So always go back and double check, because if you feel like you missed something or you had problems where that number was wrong and you just guessed on the right one, you can always have me go back and check on your test to see if I can give you some extra points based on your work. So I'm looking at the last few sections, so from 7.3 on, which talks about assuming that a distribution of the means is approximately normal. And so we can do that under a couple circumstances. So if it's a problem where it was skewed or bimodal or approximately normal, they'll give us the mean and the standard deviation in the problem. So the way that I can use an approximately normal distribution for the mean distribution is if I have one of two things. If I have the original being normal or approximately normal, which is true in this situation. So they're telling me that this is approximately normally distributed. So that means that I can use it, it's good. Also, if my sample size is at least 30, so 30 or more in my sample, notice that this wouldn't have met that requirement if the original wasn't approximately normal to begin with. In this next example, we'll do it given a probability proportion. And so in that one, you have to check the sample size times that population proportion and the sample size times the conjugate, so 1 minus the proportion, and those have to be both at least 10. So if that number is 10 or larger, then I'm allowed to assume that it's approximately normal and use the formulas. So again, I'm doing kind of everything that'll be asked in the problems. You'll have some problems that will just ask you for the standard deviation. They might just ask you for the mean. So you might just have to do a little chunk of what's going on in each of these. So we're given a problem with a mean of 205. So mu is 205. And then a standard deviation of 9.2. And we've got a random sample of 15 scoops. So our N is 15. And again, that's not 30 or larger, but because it was originally normal, then we're good to go. And then the question is asking us to find the probability that the mean number of pieces, so that's going to be the mean of my sample, will be less than 200. Okay, so I want to find the probability that the mean of my sample is less than 200. So what I need to do is find the mean and the standard deviation of my mean distribution. So it's easy for mean. It's the mean of the population. Okay, so I'm going to assume that the mean of my sampling distribution or my mean distribution is also 205. The formula for the standard deviation is the standard deviation of the population divided by the square root of the sample size. So in this case, that means that we're doing 9.2 divided by the square root of 15. And so if I calculate that, that is approximately 2.375. And I'm just looking at these because I did the problems ahead of time. So you would be calculating them. Okay, so if I want to find the probability that X bar, the mean of my sample, is smaller than 200, then I need to convert that to a z-score and use the z-table to find my probability. So the corresponding z-score here is going to be X bar minus the mean of my mean distribution divided by the standard deviation of my mean distribution, which means that I'm going to take 200, subtract 205, and divide by that 2.375. And so this gives me that my z-score is negative 2.375. 0.11. So that means that my probability that the mean is less than 200 is equivalent to finding the probability that the z-score is less than negative 2.11. So remember that when it's less than like this, I'm just looking at the z-table for negative 2.11, because remember the drawing on the graph is to the left, it's the less than side. If it's greater, then I have to do a little bit extra to get there. So I'm looking for negative 2.11. So if I look at this negative 2.1, remember this first column represents that the ending value is 0. I want the ending value to be 1. So it's this number here, 0.0174. So I'm going to use 0.0174 as my answer. Okay, so the answer here is 0.0174. So that was when I was given something approximately normal. In the next problem, I'm going to be given a probability. And so in that, my formulas are a little bit different. So remember that to check to see if it's approximately normal, I have to check the sample size times the population parameter, so times that population proportion, and the sample size times its conjugate, so 1 minus that proportion. So in this problem, they give us a population proportion of 31%, which is 0.31. Okay, so 0.31, 31% of dog owners pay for someone to walk their dog. Morgan asked a random sample of 50 dogs, so our sample size is 50 dog owners in this urban area to pay, oh my gosh, sorry. Morgan asked a random sample of 50 dog owners in this urban area if they pay for someone to walk their dog. What is the probability that more than 30% of dog owners in the sample pay for someone to walk their dog? So they want us to find the probability that p hat is greater than 30%. So p hat is our 0.3. Sorry about that. I'm going to highlight so that we know that's where that came from. Okay, so I want to find the probability that my sample proportion is greater than 30%, or 0.3. So to make sure that I can use the formulas for approximately normal, which are that the sample mean is equal to that original proportion, and that the standard deviation of p hat is equal to that square root formula there. I have to check that n times p, so 50 times 0.31 is greater than or equal to 10, okay? And so if I calculate that, that gives me 15.5. And then I also have to check that 50 times 1 minus that 0.31 is also greater than or equal to 10. So that gives me 34.5, which is definitely greater than or equal to 10. Okay, so it fit the conditions, which means that I'm allowed to use these two formulas. Okay, so given that it is approximately normal, I'm going to now know that the the mean of p hat is the same as the population proportion I was given, 0.31. And that the standard deviation is going to be equal to the square root of p, so 0.31, times 1 minus p, divided by my sample size of 50. Okay, so if I calculate that, that gives me 0.0654. I put a 1 there too. Okay, so 0.6541. Okay, so if we think about our probability that we're looking for, remember we have to find our z-score. So we want to know this probability. So we're going to find the corresponding z-score and change that to that value. So remember, for this one, the z-score is going to be p hat minus the mean of p hat divided by the standard deviation of p hat. So those values that we just got. So we've got 0.3 is p hat minus 0.31 is the mean of p hat, and then divided by the standard deviation of p hat was 0.0651. And so remember that our z table always has 2 decimal points, so that approximation is negative 0.15. So I want to find the probability that the z-score is greater than negative 0.15. Remember that in the last problem, it was that our z-score is less than, so we just looked at the z-table and it was the value for whatever our z-score was. Because this is greater than, what I want to do is instead, I want to look at the percentage for the opposite z-score. Meaning I want to look at it when z equals positive 0.15. Okay, so again, that's because of symmetry going to give me the right value, because I want, if this is negative 0.15, I want the white section. I don't want the green colored section. So I'm going to look at the opposite z-score. So positive 0.15 gives me 0.5596. So that's going to be my answer. 0.5596. Okay, so that's when I'm given a population proportion instead of a mean and standard deviation. The last one I'm going to go over is a difference problem. So I'm given 2 different sampling distributions. I'm going to assume that it's approximately normal if I'm given something that is skew, normal, something that gives me a mean and standard deviation, that's when these first come up in. So if I'm given mu and sigma, and this one is only if I'm given a percentage. Okay, so I didn't make that more clear. So I have to have one of these 4 conditions in order to use the formulas for this. So I have to have been given either 2 approximately normal or normal distributions to start with, or one of them normal or approximately normal, the other one sample size at least 30, so 30 or more, or both sample sizes 30 or more, regardless of the distribution. If I'm given a percentage, I have to have the sample size times that percentage, and the sample size times the opposite, the conjugate of that percentage, so 1 minus that decimal, to be at least 10 for both. So I have to do that calculation that we did in the last problem. This one is where I'm looking at the first 3 because I'm given means and standard deviations. So let's put the information in and then determine if it's approximately normal. So I have W going on. So I have 2 different types of pencil sharpeners. So brand W is approximately normally distributed. So one of them is approximately normal with a mean of 4.6 and a standard deviation of 0.67. The number of turns needed to sharpen a brand H is also approximately normal. So yes, I can do this because they are both approximately normal. So this one's mean is 5.2, and this one's standard deviation is 0.33. Notice that my sample is actually 30 for both. So if 30 pencils of each brand are randomly selected. So I could also say n is greater than or equal to 30 for both. This fits under 2 conditions for us to assume that it's approximately normal. Okay, so we've got 30 as our sample size for both W and H. So the question is asking us to, what is the probability that brand W pencils will have a higher mean number of turns needed to sharpen than brand H? So its mean is higher, it's larger. So I wrote that in an expression here. So they want us to find the probability that x bar of W is greater than x bar of H. If I think about that in terms of a number, because I need a number to be able to find the z-score to be able to find a probability. So if I think about it this way, that means that the probability of, if I were to subtract x bar H from both sides, that would mean the probability of their difference is positive, is greater than 0. So that means that when I'm using my formulas, I'm going to use this 0 as my x bar in the z-score formula. So remember, that was z-scores. We're looking at z equals x bar minus the mean of x bar divided by the standard deviation of x bar. Okay. So the two formulas that I need are the formulas for mean and standard deviation. So they are as follows. So whatever this here is, that's the same order that I should subtract my mean. So since I'm subtracting W from H, I'm going to subtract my means that way. So the mean of W was 4.6 minus the mean of H was 5.2. So that's going to give us a mean of negative 0.6. Okay, then we want to do the standard deviations. The standard deviation is this formula. So I have to take the square root, the sum of each standard deviation squared divided by the sample size. So in this case, I'm doing the square root of 0.67 squared divided by 30 plus 0.33 squared divided by 30. And so calculating that, I get a standard deviation of 0.1364. So to find my probability, I need to find the z-score. So remember that my x bar is the 0 from this problem here. So from my difference, it's that 0. And then my mean is the value from this mean difference. So I've got negative 0.6 divided by my standard deviation of 0.1364. So this gives me a z-score of approximately 4.4. Okay, so I'm going to write down here. So I want to find the probability then that my z-score, because I converted this to a z-score, is greater than 4.40. Okay, so greater than means I'm going to look at negative 4.40 on my z table instead. Okay, so what I want you to notice is that that number, 4.4, is not on my z table. So if I look at the biggest number is negative 3.49. Right, that's 0.0002. So anything that's bigger than this, it's going to be, or should I say smaller than this, because that's a negative number. Anything that's smaller than that is going to be approximately 0. If instead I was looking at this side and I was trying to go bigger than 3.4, look at this, is 0.9998. So that's approximately 1. Okay, so based on this, that means that this probability is approximately 0. I'm just going to write down that if it was positive 4.4, our answer would be that it's approximately 1. Okay. So again, those are the bigger concepts. So hopefully that helps with your working on the test or the review or studying or all of that.